Okay, we're going to work a little bit with the binomial PDF formula, and that formula is given here. X is the random variable. X is counting the number of successes in n trials. So that's indicated right here. So X can take on values from 0 to n. P is the probability of success in a trial, and Q is the probability of failure. So that means that Q, since there's only two possible outcomes, Q is 1 minus P because they'll be complements. Okay, so the probability that X takes on a particular value is given by this formula. Now let's look at this a little bit. I actually don't love the notation here because capital X is the value for the random variable. So let me make this a little bit better. The probability that the random variable takes on some value k, I'm going to call it like little k, where k is, one of these values. K is either 0 or 1 or 2 or any value up to n. So the probability X is equal to k is going to be, this coefficient, and that coefficient is just n choose k, and that's the number of ways of selecting k items from n times the probability of success, that occurs k times, and then the probability of failure, which is 1 minus p, that occurs n minus k times. So that is the probability X is equal to k. That might seem a little intimidating right now, but I'll do it a bunch of times so that you'll get used to the idea. But also, we're going to do this calculation using the calculator, so it'll be pretty easy. Okay, so in this first example, we're tossing a coin 3 times. The random variable is counting the number of heads in 3 tosses. So X is equal to the number of heads in 3 tosses of a coin. So X could be, what values could X take on? Well, there could be no heads in 3 tosses, 1, 2, or 3 heads in 3 tosses. So if we make the probability distribution for X here, so these are the values for X. So if X is equal to 0, what's P of X? Well, the probability X is equal to 0, there's 3 tosses. We'll choose 0 of them. What's the probability of, success, which is getting ahead, in any of the tosses? So the probability of success, so P, which is the probability of success, that's just equal to 0.5, assuming it's a fair coin. So success occurs with probability 0.5. That occurs 0 times, and failure, which is 1 minus P, that occurs 3 times. So that's what it is. If we want to know the probability X is equal to 1, then 3 trials choose 1. Success occurs 1 time, and failure occurs 3 minus 1 time, or 2 times. Probability X is equal to 2. There's 3 heads, or 3 trials rather. We want 2 of them to be heads, so it's 3 choose 2 ways of that happening. Success occurs in 2 ways, and failure, which is 1 minus P, occurs 1 way. And then the last case is 3 heads in the 3 tosses, and 3 choose 3. 0.5 occurs 3 times, and then 1 minus 0.5 occurs 0 times. So how do we do these calculations? Well, we can do these calculations in your calculator. If you turn your calculator on, there is this whoopsies. This feature right here, distribution, which is second vars. If we look at the probability distributions that are built in here, you have to scroll down. The first distributions are continuous distributions. But so we want the binomial PDF. We want 0 colon. So if we choose 0 colon, I think the syntax is n, which in this case is 3, because there's 3 trials. P, which is the probability of success, in this case is 0.5. And then the value of x, or what I'm calling k here, now that varies. In the first case, it's 0. So that's 0.125. So that's what this is equal to. And if we do the binomial PDF, again, there's 3 trials. The probability of success in one trial is 0.5. But now we're interested in the probability x is equal to 1. Then we get 0.375. And the next case, again, 3 trials. Probability of success in a single trial is 0.5. But now we're interested in the probability of having 2 successes. Again, we see it's 0.375. And the last case is having 3 successes in the 3 trials. And you can see that that's 0.125. Now, if you add up all of these cases, the sum of P of x here, since this is a probability distribution, this will add up to 1. And this is the same as the result that we had gotten before spring break when we found the probability distribution for x using this sample space. We did that, again, before spring break. Okay, so we'll continue with this with the next example in a few minutes.